This is the video solution to practice problem A that accompanies sample problem 7.3 on page 287 of the textbook. In this problem, we are asked to place three elements in order of increasing radius based on their position in the periodic table. The elements are germanium, selenium, and fluorine, and here they are on the periodic table. We already know that the trend in atomic radius is that it increases as we move to the left within a period and down within a group of elements. Based on this trend, we could say that fluorine would have the smallest radius. Of the two that remain, selenium would be the next smallest, and germanium would be the largest. Germanium is the farthest to the left and down of the three elements. When we write out the answer to this question, we'll begin with the smallest and work our way up to the largest. This particular question, though, only asks us for a very superficial answer. Use the trend, determine relative sizes. A much more complex question would ask you to explain your reasoning, and you'll definitely encounter a question like this when you're taking a quiz for Chapter 7 or an exam. So let's cover the explanation to help you prepare. Fluorine is found in period 2. Germanium and selenium are found in period 4. We can say that fluorine is the smallest element because the highest energy level in which electrons are found in fluorine is the n=2 shell. For germanium and selenium, the highest energy level in which electrons are found is n=4. Every new energy level occupies more space around a nucleus, so fluorine is smaller than selenium and germanium. When comparing germanium and selenium, these elements are in the same period, so we have to evaluate effective nuclear charge. When we estimate the effective nuclear charge on a valence electron in germanium, we find a value of 4. Effective nuclear charge is the number of protons, in this case 32, minus the number of core electrons, and germanium has 18 plus 10, or 28, core electrons. Therefore, a valence electron in germanium feels an approximate effective nuclear charge of plus 4. Using the same argument for selenium, we find an effective nuclear charge here of 6. Selenium has 34 protons and 28 core electrons. So of these two atoms, we would say that selenium is the smaller because a valence electron in selenium experiences greater effective nuclear charge. This charge tends to pull electrons closely and results in smaller atoms. So the ideas of energy levels and effective nuclear charge are the actual explanation behind the order that we arrived at just based on our periodic trend. Please take some time and try practice problem 7.3b. You can check your work with the answers that are shown in the back of the chapter.